In this example, we're going to consider what happens when the two containers of water are at different temperatures. So I'm going to put water in both containers, and they're both going to have the same amount of mass. And I'm going to start with the beaker that is on the scale being at 40 degrees Celsius. And I'm going to put water in this calorimeter, same amount of water, 100 grams, but the temperature here is going to be at 20 degrees Celsius. So the beaker that has the 40 degrees Celsius water is at a higher temperature. It has more internal energy, and I'm going to go ahead and I'm going to start the simulation. I'm going to mix them together, and we'll see what happens in terms of them reaching some equilibrium temperature. So the calorimeter is going to cause the two to mix together, and the higher temperature object is going to lose energy, so its temperature is going to drop, and then the cooler object is going to gain energy and its temperature is going to rise. And so the simulation has finished, and we realize that the equilibrium temperature is 30 degrees Celsius. So we're mixing two identical substances, both water, and one was at 40 degrees Celsius, the other was at 20, and so the equilibrium temperature is halfway in between because it's equal amounts of the substance. Let's reset this, and let's take the mass of the, reset, and I'm going to choose the first substance to be water, and this time I'm going to put twice as much water in. So I'm going to set this at 200 grams, and at 40 degrees Celsius, 200 grams, twice as much as the container in the calorimeter is going to have water in it, and I'm going to set that at 100. And I'm going to start that at the temperature of 20 degrees Celsius. So let's see what happens and what we expect to happen. So the mass of the beaker that's outside is at 40 degrees Celsius, but it has more mass. Because it has more mass, it has more internal energy. So it has more energy that it can give to the cooler water. So let's go ahead and hit start and see what happens, and see what that equilibrium temperature turns out to be. So the higher temperature object is losing energy, the cooler object is gaining energy, and so we expect that the equilibrium temperature in this case is not going to be 30 degrees Celsius because of the fact that you had more water that was warm compared to the cooler, and we see that the temperature is actually higher than 30 degrees Celsius in this example. And that is because the higher temperature object had more mass associated with it, and therefore its temperature does not change as much. It went from 40 down to 33.3 versus the cooler temperature object, which went from a temperature of 20 degrees Celsius up to 33.3. So its temperature change was 13.3 and the other was 6.66.